thanks a lot for attending. One side note, we got our marketing material, so Walter will hand on some pens afterwards. So I would like to introduce or show you a little bit about what you can do with Qt 3D and 3D in general on embedded devices. Yeah, we will cover what 3D is, what you have to care about if you use 3D on embedded devices, and I would also like to show you a demo. However, I don't do it on the hardware because yeah, I can break things then. So shortly about me, I work for Toradex. I have an embedded background, so I did a lot of Linux and BSP stuff before. I also gained some Qt experience during this time, and I love to test new things. That's why I'm basically doing this talk about 3D. However, I'm not a designer, so everything I do looks quite ugly. So yeah, don't judge me on that. Then I would like to know something about you. Who of you is a Qt developer? I hope most of you. Okay, almost everyone. And who has some 3D experience with Qt 3D? Okay, only 2 or 3 people. And who is mainly an embedded developer? Okay, most of you, so that's good. So the first question I ask myself, why should you care about 3D? Is anyone familiar with one of this project? The left one is basically Project Looking Glass, and the right one is Compits. So they are more than 15 years old, I think now. And the left one is a 3D desktop written in Java, and the right one is a compositor for Linux. Nowadays it moved more to Mutter and Kevin and things like that, and they stole some stuff from there. However, it's not about that. So I think 3D desktops are not really usable because they don't give you any benefit. So it's not about that, but about what is it then? So it's basically if you want to show context. So if you have a user and you want to show this user some context between objects in the real world or in a virtual world, then you can benefit of 3D. Here you can see these cars. These cars are basically somewhere in the world, and you as a user want to know where are the cars and how are they located on the world. How is the relationship between these cars? You could also do that in 2D, then you would only do a top view. However, that never looks as nice and user-friendly as if you would do it in 3D. Then some things about OpenGL and embedded devices. So if you work on embedded devices, you don't have a fully OpenGL version available normally. It's a reduced version. It's called OpenGL ES. A lot of SOCs support OpenGL as ES 2.0. Some of them may or may not support some feature also from newer versions, even if the SoC provider basically say it's only 2.0. However, if you want to be sure and you develop for embedded devices, only use OpenGL ES 2.0. If you're anyway targeting newer devices, then you can go with OpenGL ES 3.1. The nice thing about Qt 3D, however, is that it wraps basically OpenGL, so you don't really have to care about that, and it will automatically downgrade if it sees the GPU basically doesn't support these features. Then the other thing I didn't fully understand when I did this talk is how are this or prepared this talk, how are these components of Qt related? So basically every embedded device that allows you to attach a display has a display driver. Even the devices that don't have any GPU still have a display driver. Then the one with GPU, they have an OpenGL backend, so or an OpenGL library, which is used to basically do the 3D stuff. The Qt, declarative stuff, that's the cute quick stuff, that is basically using the default scene graph, which is using OpenGL in the background. OpenGL is there used to have nice transitions between tabs and to animate buttons, but it's not used to do actual 3D rendering. It's only to speed up 2D animations. Therefore, it's also possible to basically have the 2D renderer instead of the 3D renderer, or the OpenGL renderer. So there is nowadays the 2D renderer available, which does everything in software. Then you, of course, do not need to use OpenGL. However, Qt 3D is a little bit different. It just really wraps OpenGL, so it doesn't use Qt declarative at all. It only uses it to get a window. So Qt 3D basically is using Qt quick to create the window and to know where it has to paint to. Then there are two other frameworks, that's Kuesa and Qt 3D Studio Runtime. The Qt 3D Studio Runtime was using Qt 3D up to 2.4, and now it uses again OpenGL directly. So they changed a lot between OpenGL and back to Qt 3D. And Kuesa, which is maintained by KDAP, is basically using Qt 3D. And the demo will be basically about Kuesa and not that much about Qt 3D Studio Runtime. So as I said, Qt 3D wraps OpenGL. That means you don't have to care that much about memory handling, initialization, and you can use it in a much more declarative way. So you can declare objects, then you can assign materials to these objects, and you can do animations on a really high level. And if you want, you can even use QML instead of C++. The Qt 3D Studio is basically a tool that allows you to define scenes. So if you have different objects, you can place this object somewhere in the world, and then you can even do animations on them. So you can basically, for example, allow this robot arm to do some movements. It allows you to assign materials. And the nice thing about Qt 3D Studio Runtime, it's now part of Boot to Qt. So if you use Qt 3D Studio, you will benefit of the features of Boot to Qt directly. So it will work out of the box. And the main driver of Qt 3D Studio is basically Qt. The other thing that almost does the same, however, it doesn't use a 3D tool like the Qt 3D Studio, is Kuesa. The idea behind Kuesa is a little bit different. Instead of having a separate tool, where you define the scenes and the animations, you directly use your 3D design tool like Blender or 3ds Max, and then you export your scene and your animations into a GLTF file, which then can be loaded by the Kuesa runtime. This project is not part of Boot to Qt, and I think it will never be part of Boot to Qt, so you have to compile it yourself. However, it's doable. It's not super complicated, and the project is mainly driven by KDAP. So, a short overview of what should I use? What should you use when? Of course, it's my perspective, but I think can help a little bit. So, OpenGL, if you use Qt, you probably won't use, because it's really more to write engines. It's so low level that if you want to develop an application and you have to care about OpenGL, it can be quite hard. Qt 3D is for research projects and data visualization, where you really control the objects, or you even have to generate 3D objects out of the box. And then the other two projects, Qt 3D Studio and Kuesa, are really high-end, high-level tools basically, and high-level engines that you can use if you have final scenes and you have defined animations in the end. You have different tools available. I said Qt 3D Studio. There is a Kuesa viewer where you basically can inspect your GLTF file if you export it, and then you can analyze what parts are in in the GLTF file, what kind of animations you have. We will see that later. One thing about OpenGL, by the way, OpenGL is a standard. If you don't know that, it's from Kronos, and there are a lot of vendor-specific implementations. So even if a vendor claims he supports OpenGL as ES 3.1, it doesn't necessarily mean that the driver really is capable of doing that. So it's sometimes a little bit hard. If you are lucky, then there is a Mesa driver, which is basically open source, and then you can use that one. So the example project, which I created for this talk, basically, the idea for that was to have a robot arm, because robots are cool. And I wanted to animate them so that I can control the robot, and I would have a 3D animation of the same robot. And the whole thing should run on an IMX8 Quad Max. That was the idea. However, I unfortunately failed with the free animation. So now I have an animation that is defined, but it will always do the same animation. I can't really control it with joysticks or something like that. But it runs, of course, on a IMX Quad Max. So yeah, then let's try to switch. I forgot that I should show you some stuff. So the microphone is maybe a little bit a pain, but let's try to do it anyway. So how do you start when you try to develop with Qt3D? So as I said, I chose Kuesa in the end because it worked better for this use case, because I had to have some constraint on bones. So if you model your robot arm in this case, the bones are basically... Oh, no, it's oh, okay, perfect. Oh, that's good. Okay, so basically, if you have to use bones to model your object. So the bones describe how movements are possible. These colored bones have some restrictions, so they cannot move freely. Because if you would do it the other way around, if you would say, yeah, you can move a bone as you want, then if you move this bone here, then it would move the whole model simply in the same direction. But you have a screw here, and you have to tell the model somehow that there is a screw there. So if we check that, so we can select pose mode, that's already good. So in the end, what you do with bones, you define how your object basically behaves. It's the behavior, the description of the behavior of your model. Normally, you then assign vertices. So vertices are the points of your model to these bones. But that doesn't work with Kuesa at the moment, at least if you export it with Blender 2.8, which I use. By the way, who is using? Has anyone experienced with Blender? Did you use Blender 2.8 or a version before? Yeah, an earlier one. Because Kuesa basically supports, has its own exporting tool for Blender versions below 2.8. But Blender 2.8 is much more user-friendly, and it has an included GLTF export function. But if you export it with that and you have bones in it, then Kuesa will crash. So Kuesa is not ready yet for handling the new Blender GLTF files. However, I hope it will be fixed somewhere in the future. So what you have to do, basically, you have then to animate your model. So I will load the animated one. And these animations are now only defined on the bones. They are not baked to they are not in the objects or in the vertices. So only the bones are animated, and the whole model will follow the bones because they are assigned to these bones. And now it comes the tricky thing, because we can't export bones. We have basically to bake the model, but we have to bake the animations onto the object so that we can eliminate the bones. And that's basically quite easy. You have to press F3 and then you say bake. Then you have to select clear constraints, which means you remove this assignment of the bones to your object. You have to use visual keying, and you have clear constraint, I've already said. And then you have to bake it on the object, and what happens, we'll see quickly. So basically now I should be able to delete the bones, and the animation is still there. So by baking the model, I basically eliminated the need of the bones, and now I can export that to GLTF, which is done with this plugin. And you simply have to say, don't export the bones or the skinning. It's the same. Bones and skinning means the same. I don't do that. It's really only a click, and then it will do it. So afterwards, you can already import this model into Kuesa. This one is the Kuesa editor. You don't have to edit anything in that edit, but it's nice to check what kind of animations you have. You can also see actions, materials, and things like that. You can inspect your 3D model with the GLTF editor. This one, it's not for use, but it's just to inspect your 3D model. Afterwards, I'm in the old project, so I have to load it. In QML, you have to compile the Kuesa sources for your target, which should be not that complicated. You have to select the right QMake, and then it should generate the make files accordingly. And when you did that and you have installed everything, you can basically only say, I want to import my GLTF file into the QML scene. And you have your animations that we saw before, basically here, these actions available in QML, and you can start them. The nice thing is also you can loop them. So what I do here is I simply start them and I loop them forever. And that's all. What I also did, I added some kind of skybox to this scene, that you have some nice animation. And what is the most important thing, don't forget the environment. The environment lighting, because if you don't have any light, then you basically won't see any object in your scene. Here you can then select Qt Desktop, run it, and then you have your model finally available on the PC. If you would select boot to Qt instead, then you will compile it for the target, in this case the IMX8 Quad-Max, and you could deploy it. However, I don't show you that here because I was scared it won't work, but I made a video. So it's the same thing here. That was before it started. Then I simply click run. First I didn't hit the button, and it didn't work, but and now you see the same model. However, if you look closer, you will see that, for example, anti-aliasing doesn't work here correctly. I think the problem is that it's still not, that it's still made for the IMX6, the whole Qt 3D stuff, and it's not aware that the IMX8 basically should support it. and therefore you have this not so nice squares in your scene. The other thing, the lightning is behaving a little bit different. That one I didn't figure out why. But then the really nice thing is basically, even if some features are not supported by your GPU, it will still work probably. It doesn't look that nice, but it nicely downgrades because Qt3D takes care what features are available and what features are not available. Okay, so I already come to my ending. So if by using Qt3D, you can basically increase your maintainability of your source code because it abstracts OpenGL really nicely. It speeds up your 3D development. To even go further, if you have scenes and animations, then you can go for an engine like Qt3D Studio or Kuesa. And boot to Qt, of course, if you want to run it on an embedded device, will give you a really fast out of the box user experience because you simply can hit run and it should compile it for your embedded device and then deploy it to it. So yeah, thanks a lot for your interest. You will basically find the source code on my GitHub repository if you want to take a look on it. Yeah, thank you. Yeah, do you have any question? Maybe.
So the output of Kuesa will be something that you can embed in your other Qt Quick QML code?
Yeah, exactly. You can. It's really simple QML code, and it uses the Qt3D scene. I can show that here. And you could even add normal QML elements if you would like to. So you could use buttons, 2D stuff. That would work as well. Other questions?
Thank you very much.
Okay, thank you. Don't forget to catch a pen because I don't want to bring them back to Switzerland.